This is for Year 12 Special. It's a continuation of question 22 from 6F. In the previous video I showed how to get the values for A and B. Find the value of t for which the area is equal to 4 root 3. At the end of part B I found out that this was the area, so I'm going to set that equal to 4 root 3 and solve for t. We've got 2 sine t on cos squared t equals 4 root 3. I can halve both sides and get sine of t over cos squared of t equals 2 root 3. Then if I move my cos squared t, I've got the sine of t equals 2 root 3 times the cos squared of t. Since I'm trying to solve for t, I've got sine and I've got cos. I can use the identity sine squared t plus cos squared t equals 1. Therefore, cos squared t equals 1 minus sine squared t. So I've got the sine of t equals 2 root 3, 1 minus sine squared t. So it's now in terms of sine of t, so I'll be able to solve for sine of t. Move everything over, I've got 2 root 3 minus 2 root 3 sine squared t minus sine of t. Multiply everything by negative. 0 equals 2 root 3 sine squared t plus sine of t minus 2 root 3. I'll use the quadratic formula, and that will solve for the sine of t equals minus b, so minus 1, plus or minus the square root of b squared, which is 1, minus 4 times 2 root 3 times negative 2 root 3 all over 2a, which is 4 root 3. It's going to equal negative 1 plus or minus the square root of 1 minus 4 times 2 is 8 times 2 is 16 times 3 is 48, and it's positive, on top of 4 root 3. I've got negative 1 plus or minus 7 on 4 root 3. So the sine of t equals negative 1 minus 7 on 4 root 3, or negative 1 plus 7 on 4 root 3, which would be 6 on 4 root 3, or negative 8 on 4 root 3. Given that I've got positive answers here, the sine of t has to be positive because I've got areas of triangle. So I'm going to ignore that answer, and this is the same as 3 on 2 root 3. If I times by root 3 on root 3, that will give me 3 will cancel with those 3's, root 3 on 2. So the sine of t equals root 3 on 2, therefore t equals pi on 3. And that's the answer to 22C.